let's look at how to find the least or greatest value of a quadratic equation. Now, the least or the greatest value of a quadratic equation is the same as the maximum or minimum values of a quadratic equation. Okay, they are the same thing. So when you are given the equation, first of all, you should be able to tell yourself whether the equation is going to have a minimum or maximum value. Immediately look at the equation. You should be able to say it whether it's going to give you a maximum value or a minimum value. So here, if you look at this, we have 4x squared minus 4x plus 3. So from this one, we can quickly look at it and know whether when we draw this graph, we are going to have a maximum or minimum. Now what do? We use the coefficient of what? X squared to determine it. If the coefficient of x squared is positive, then it means the graph is going to have a minimum value. And if the coefficient of x squared is negative, then when you draw such a graph, you are going to have a maximum value. So from these two equations over here, we have this one, equation 1, and the equation 2. You can see that this graph over here is going to have a minimum value, and this graph over here is going to have a maximum value because the coefficient of x squared over here is negative. Okay, so after knowing this, what do? We just take by not drawing the graph, you should be able to find it using the analytical method. Okay, so let's take the first one as an example. We use difference of completing of squares. Okay, we use completing of squares to find the maximum or minimum value. Okay, now what we do over here is to factor the coefficient of x squared out. We factor coefficient of x squared out. That's the first thing to do. Okay, so when we do that, we are going to have we factor 4 out, then we have x squared here minus 4x. Because we factor for the coefficient of x squared out, meaning this term is going to have out of 4. Then we have 3 will also be out of 4 over here. Okay, so that when you push in this 4 cancel this one off, and it will cancel this one off. Okay, now what do we do next? Then here we could see that we may have 4 cancel 4 over here and give us a negative 1. So we have 4 here, x squared minus 1x plus 3 out of 4. Okay, so at this point, what do? We take the coefficient of x. Okay, we take coefficient of x, which is negative 1 over here, then we divide it by 2. Okay, we take coefficient of x over here, which is negative 1, we divide it by 2. So in doing so, we have minus 1 divided by 2, and this is going to give us negative 1 out of 2. Okay, so we put this one, the result in bracket like this, and square it. So what do we do with this? We add and subtract it to the equation. Okay, we add and subtract it to the equation. So we have 4, we have x squared here minus x. Okay, so we add plus minus 1 out of 2 square. Okay, then we subtract again, minus 1 out of 2 square. Then we bring our last value over there, which is plus 3 out of 4 over here. Okay, so this is the procedure of finding the least or the greatest value. So at this point, we can compress these 3 terms over here. We can compress them. They are perfect tri-square, so we can compress them and have x, okay, minus 1 out of 2 all square. Okay, then we simplify these ones over here. So we have minus 1 out of 4 here, okay, for this expression, plus 3 out of 4 over here. Okay, so at this point, we have x minus 1 out of 2 all square Then we can simplify this fraction here. We can see that we have a like fraction over here, so we add the numerators and maintain one of the denominators. So minus 1 plus 3 will give us 2, so we have 2 out of 4, which will give us 2 out of 4. And this one, at this point, what we do over here is we push in this 4. Okay, so we push in this 4, we multiply them by each term over here. So you may have 4 multiplying x minus 1 out of 2, okay, square. So this 4 can multiply this term again, 2 out of 4 times 4 over here. Okay, so in this case, this will cancel this one off, and this will leave us with 4 multiplying x minus 1 out of 2 plus 2. Okay, so this is our last point. Okay, this is our last point. So what we do over here is the value over here becomes either the maximum or the minimum. Okay, so from the graph, as we stated earlier, because the coefficient of x squared is positive, we are going to have a minimum value or a least value, and the least value for y in this situation will be what? 2. So if the graph is a if the graph will have a maximum value, then the value that you get over here becomes the maximum value or the greatest value of y. Now this is the greatest value of y. It means at the turning point, the value of y at the turning point is 2. Okay, is 2. Now the question continues and says, and the values of x at which it occurs. The values of x at which it occurs. So the value of x at which it occurs, we take what is in the bracket. Okay, so we have square here. So we take what is in the bracket over here. So we have x minus 1. Then we equate it to 0. Okay, we equate it to 0 and make x the subject. So we have x to be equals to 1 out of 2. So the value at which the minimum point is occurring is x equals what? 1 out of 2. This statement over here is what we term as what the equation of the axis of symmetry. Okay, so this is the equation of the axis of symmetry. We have the maximum, the minimum value over here, or the least value. So the minimum or the least are the same, as well as the greatest and the maximum are also the same. So at this point, the least value for the first equation over here, the least value for this equation over here is y equals 2. Is y equals 2, and it occurs when x is equals to 1 out of 2. You can see this one looks a little bit simple. Okay, anytime you have to ask to find the maximum or the minimum, maybe find the least or the greatest, just check the equation. If the coefficient of the equation is negative, if the coefficient of x squared is negative, then we are going to have a maximum value. If it is positive, then we are going to have a minimum value. Then follow this procedure over here. Then at this point, the last value over here becomes your maximum or minimum point. Okay, that's for y. Then the point at which it occurs, or the value of x at which it occurs, we take what is in the bracket. Okay, excluding the negative, the exponent and the scalar over here. Okay, excluding the exponent and the scalar. So you take what is inside the bracket, equal to 0, and make x the subject. So this equation is also known as the equation of the axis of symmetry. Okay, so just try your hands on the maximum value. Use the same procedure over here, and whatever value will be left will be the maximum value. And the point at which the value of x at which it occurs, you take whatever you get in the bracket and equate it to 0 and make x the subject. I hope this one look a little bit simple and easy. Okay, so look at it, take care, and solve this one as your own revision question. Okay, thank you, bye bye.